Hey guys, we're going to talk about what happens to momentum whenever two things collide. So what I want to do is I got to make sure everything looks good here. Let's see, I got to visualize my screen so I can go down to here and you can still see. Yeah, that'd be great. Thanks, hon. All right, so what we're going to do is I stole this from Khan Academy. You're going to pretend, we'll just call this example 1. And you know what we're going to call this? Let's see. So we're still in chapter 9. So we're going to call this the 9.2 and 9.3 momentum momentum impact notes. How about that? Hey Nate, is there any way I can have some more lead? Oh, wait. Yeah, I'm really sorry about the title, guys. I have lead in here. About the title of all these notes, but just bear with me. Okay, I'm doing my best to try to keep them in order. Please make sure that your titles match my titles. All right, so let's say that we have like a billiard ball. We'll just call it ball A, and we hit it and it's rolling along and it has a velocity of 3 meters per second. And then what's going to happen is it's just going to grace ball B. And after it does, ball A is going to have a new velocity of 2 meters per second, but now we have a diagonal, and that happens at a 30-degree angle to the horizontal. Well, what do we know is going to happen to ball B? Ball B is going to like go down here, right? But I'm not going to tell you at what angle, and I'm not going to tell you its new velocity. We're going to kind of figure that out. So something really important to understand is that the original, I hope my volume's working. The original momentum of a problem is going to equal the final momentum of a problem. And that's going to take us to where we're going to go. Something I neglected to tell you is that ball A is 10 kilograms and ball B is 5 kilograms. So make sure you make that note when you're taking your notes. So the first thing we're going to do is we need to figure out the initial momentum. But what's different about this problem than in the last couple of problems we've been doing in like yesterday's notes and yesterday's homework was the momentum was just in a linear path, like just one line. It wasn't two-dimensional like this one, because this one's going to end up being two-dimensional. It's going to have an X and a Y component. So let's just focus on the initial. So the initial stuff's happening over here, right? So let's solve for the initial momentum. But let's acknowledge that since it's going to have an X and Y component at the end, let's give it an X and Y component now. So let's talk about the initial momentum, but let's talk about it in the X direction. So the initial momentum in the X direction is going to be my mass times my velocity. So 10 times 3. So my momentum is 30. Now we also probably need to talk about my initial momentum in the Y direction. My initial momentum in the Y direction is how big it is, 10, times how fast it's traveling in the Y direction, so 0. So the momentum initially in the Y direction vertically is 0. So now what we're going to do is we're going to focus on ball A at the final over here. Okay, so we're going to look at the momentum of A. Now, notice A was the only thing moving at the beginning, okay? So let's talk about, ready, look at all these labels, you're going to love them. Let's talk about the momentum of A finally in the X direction. I'm sorry about all those labels, but it is what it is. So we're looking at the momentum of A, the final momentum of A in the X direction. So the way that I'm going to do that is, well, that's the X direction is this line here, so that would be adjacent, so it's cosine. So it's not 2 meters per second. Its velocity in the X direction is not 2 meters per second, okay? No matter what, its mass, so we can do mass and velocity in the X direction. No matter what, its mass is 10, all right? Mass is mass. And in the X direction, it is moving a speed of 2 cosine of 30. So if I grab my calculator, make sure you're in degrees. If I do my mass times my 2 cosine of 30, because 2 is the hypotenuse, cosine of 30, it helps you identify the adjacent, I get 17.32. And that is that's momentum. That is positive because it's moving to the right. Now what we're going to do is we're going to figure out the momentum of A, the final momentum of A in the y direction. So it's still mass, but this time it's velocity in the y direction. So we're going to do 10, because it has not changed its mass, times 2 for the velocity sine of 30. So 10 times, sorry, I forgot my time symbol. 10 times 2 sine of 30 is going to be, well, just 10. Why don't I like that? I guess it's right. I don't know why I feel so wrong. Okay, 10. Now, if you wanted to check that you were right, you can't. I think that's fine. I don't know why I don't like. That's because sine of 30 is what? Hold on, guys. I'm having a moment. Sine of 30 is a half, so that all makes sense. Okay. So that's the momentum, the final momentum of A in the x and the y direction. Okay, so now what we need to talk about is that the final momentums of A and B together, if we are in a conservative system, which we're going to say we are in this one, they need to add to the initials. Maybe you want to write that down, like as long as it's stated that yes, the final momentums add to equal the initials because we're conserving our momentum here, you can write that down. You're going to say that the initial momentum, let's do this. Let's write total initial momentum in the x direction is going to equal the total final momentum in the x direction. Okay? And then that's going to be same for the total initial y direction momentum has to equal the total final momentum in the y direction. Okay? So initial has to equal final. But the problem with this particular problem is that the x direction is made up now of ball A and B, and the y direction is also made up of ball A and B. So we have to kind of like take that into consideration. All right, I promise it's not too hard. So what we're going to do is we're going to say, we're going to say that the initial momentum in the x direction equals the final momentum of A in the x direction and the final momentum of B in the x direction. And then we're going to say that the initial momentum in the y direction needs to equal the final momentum of ball A in the y direction added together with the final momentum of ball B in the y direction. Okay, so we're just breaking them down to their components, saying initial needs to equal the finals added up. All right, so the initial momentum in the x direction was 30. And we were able to, because we knew the velocity, we were able to say that the final momentum of A in the x direction was 1732. And we were not able yet to calculate the final momentum of B in the x direction. So I'm just going to write final momentum of B in the x direction. I might be labeling these weird, but to me that makes sense. So when I subtract that, 30 minus 17.32, I need to say that 1268 equals my final momentum of B in the x direction. Now remember, momentum is simply mass times velocity. So I can say that 12.68 equals my mass of ball B times my velocity of x of ball B. Okay? Well, I know my mass of ball B is 5, so I can say 1268 equals 5 times the velocity in x direction. Remember, this is for ball B. Maybe I should add an extra B in there. So if you divide by 5, you get 2.536 meters per second. And that is the velocity in the x direction of ball B. Now we're going to do the same thing for the y. So the initial momentum of y Well, it wasn't moving up or down. It was just 0. The final momentum of A in the y direction was 10, plus the final momentum of B in the y direction is unknown. Subtract 10. That means negative 10 needs to equal my final momentum of B in the vertical direction. We know that momentum is mass, and this one is ball B, times velocity of B in the y direction. You can do YB. Doesn't matter as long as you know that it's vertically of B. Vertical movement equals negative 10. Well, we know the mass of ball B was 5. Lily, please stop kicking the table, my love. So if we want to find the velocity of it, we simply divide by 5 and we get negative 2. Now, what do you think about this negative 2 meters per second? Are you okay with it being negative 2 meters per second? Well, I hope you are, because ball B vertically is traveling downwards. Horizontally, it's traveling right. So I'm happy that I got a positive here because I can visualize that that's going to move right. I'm happy I got a negative here because I can visualize that, yes, it does move right and it moves down. So to find the angle, let's think about it this way, okay? So here's ball B, right? Here's B, it gets hit and it's traveling like this, right? Well, what we just did is we found out this line to be 2.536, and we found this line to be a negative 2 or 2. Okay? So if we want to find out the angle, which we can definitely do, and if you want to write a negative 2 on there, I mean, you could, because watch this. That's tangent. That's inverse of tan. We've been doing this all along. Of opposite, negative 2 divided by adjacent, 2.536. So the angle is negative 38.26. So theta of B to the horizontal is negative 38.26 degrees. What I'm going to ask you to do is rewatch that video that I just did and try to make heads or tails of it until you feel like you understand. Yeah, I totally forgot, like, the most important thing is what is the velocity of B? What is the magnitude of B's velocity? I'm sorry. So we have the angle. That was actually the easiest part. The velocity of B, considering its x and y components together, is simply the square root thing, like the hypotenuse a squared b squared c squared thing. So 2.536 squared plus what's Lily 2 squared. After this, I'm gonna. What's the matter, sweet? Oh, did your phone die? You know what, mommy's at the end of this video, okay? And then you and I are gonna hang out, okay? So we're gonna do the square root of 2.536 squared plus 2 squared, and we're gonna final answer of 3.22. I guess at 3.230. 3.230. So the velocity of B, the magnitude of the velocity of B, is 3.230 meters per second. Boom. And I hope that kind of makes sense, that it's slower than A, because A was a lot heavier. So to me, it kind of makes sense that this heavy thing is going to hit this lighter one, and the lighter one's going to fly at, well, fly in quotes, at 3.23, and then the bigger one, the 10 kilogram one, it's going to go at 2, so it's not going to go as fast as the small one. All right, guys, I hope that was good. Please rewatch the video until it makes sense.